Scientists working with Large Hadron Collider (LHC) have discovered 3 subatomic particles never seen before as they work to unlock the building blocks of the universe, the European Nuclear Research Center (CERN) said on Tuesday. Hello everyone, and welcome to another video. Today we'll be looking at how scientists just announced that the Large Hadron Collider found something for the first time ever. Yeah, you heard it right. The 27-kilometer long LHC at CERN is the machine that found the Higgs boson particle, which along with its linked energy field is thought to be vital to the formation of the universe after the Big Bang 13.7 billion years ago. Now scientists at CERN say that they have observed a new kind of pentaquark and the first ever pair of tetraquarks, adding 3 members to the list of new hadrons found at the LHC. They'll help physicists better understand how quarks bind together into composite particles. Quarks are elementary particles that usually combine in groups of 2s and 3s to form hadrons such as the protons and neutrons that make up atomic nuclei. More rarely, however, they can also combine into 4-quark and 5-quark particles, or tetraquarks and pentaquarks. The more analyses we perform, the more kinds of exotic hadrons we find. Physicist Niels Tuning said in a statement, "We're witnessing a period of discovery similar to the 1950s when a particle zoo of hadrons started being discovered and ultimately led to the quark model of conventional hadrons in the 1960s. We're creating particle zoo 2.0. 10 years ago, a team operating the world's largest particle collider made history by discovering the Higgs boson particle, a finding key to understanding the creation of the universe, earning it the nickname the God particle. After a more than 3-year pause for upgrades, the accelerator, run by the European Organization for Nuclear Research, or CERN, is collecting data again. This time, it's out to prove the existence of another mysterious substance, dark matter. Though scientists largely believe that dark matter is real, none have been able to see it or create it. Data collection and power upgrades made to the particle smasher called the Large Hadron Collider could provide researchers one of their best chances to visualize and understand the substance. If we can figure out the properties of dark matter, we learn what our galaxy is made of, said Joshua Rudderman, an associate professor of physics at New York University. It would be transformative. Dark matter has fascinated physicists for decades. It is widely believed to make up a significant part of the universe, and learning more about it could provide clues as to how the universe came to be. All the stars, planets, and galaxies in the universe account for only 5% of the universe's matter. According to scientists at CERN, roughly 27% of the universe is thought to be composed of dark matter, which does not absorb, reflect, or emit light, making it extremely hard to detect. Researchers say it exists because they've seen its gravitational pull on objects and have witnessed how it helps bend light. Researchers are hoping the Large Hadron Collider can help. The collider was built over the course of a decade by the European Organization for Nuclear Research to help answer outstanding questions of particle physics. The machine is located roughly 328 feet underground in a tunnel near the French-Swiss border and the city of Geneva. Its circumference spans nearly 17 miles. Inside the collider, superconducting magnets are chilled to roughly -456 degrees Fahrenheit, colder than space, while 2 particle beams traveling close to the speeds of light are made to collide. Using advanced sensors and monitors, scientists analyze the substances created by those collisions, which replicate conditions similar to the Big Bang. It allows them to learn about the earliest moments of the universe. The machine started working in September 2008, but is shut down multiple times for enhancements. For the past 3 years, engineers have upgraded the collider so that it can detect more data and run at higher speeds. Now the accelerator can run at its highest energy level ever, 13.6 trillion electron volts, allowing scientists to run bigger, more complicated experiments that could yield new insights into particle physics. This is a significant increase, said Mike Lamont, CERN's director for accelerators and technology, paving the way for new discoveries. At the beginning of the universe, particles did not have mass, so scientists have long questioned how stars, planets, and additional life were created. In 1964, physicists Francois Englert and Peter Higgs and others theorized a force field that gave particles mass when they connected, but they couldn't document the existence of the entity. The discovery of the Higgs boson particle, a part of the hypothesized force field, won Englert and Higgs a Nobel Prize in physics. The particle has fascinated scientists and the general public alike. CERN and the collider are featured prominently in the Dan Brown book and adapted movie Angels and Demons. And now researchers want to answer more vexing questions, especially those surrounding dark matter. During the Large Hadron Collider's 4-year experiment, scientists are hoping to find evidence of dark matter. As they fire up the machine, protons will spin at nearly the speeds of light. And the hope, the researchers said, is that when they collide, it creates new particles resembling the properties of dark matter. They also hope to learn more about how the Higgs boson particle behaves. On Tuesday, shortly after the collider began collecting data, scientists at CERN announced that they'd found 3 new exotic particles that could provide clues as to how subatomic particles bind together. High-energy colliders remain the most powerful microscope at our disposal to explore nature at these smallest scales and to discover the fundamental laws that govern the universe, said Jean Guédis, head of CERN's theory department. Ruderman of New York University said CERN's quest to learn about dark matter and explain the origins of the universe has him eagerly awaiting the results from the experiment. The research excites him greatly. It's why I wake up in the morning, he said. Once data starts coming out of the experiment, Ruderman will see if it's producing new particles. Even if it does, it will be hard immediately to tell if it's dark matter or not. First, they'll need to assess whether the particle in question emits light. If it does, then it makes it less likely that it's dark matter. Second, the particle should show signs of existing for a long time and not decaying immediately, since dark matter should in theory be able to last billions of years. They also hope the particle behaves similarly to current theories of dark matter. And that's all for today's video. What are your thoughts on this? Let me know in the comments section down below. I hope that you found this video interesting, and if you want to see more videos like this, please consider subscribing to my channel. See you in the following video with some more of the latest updates, and until then, stay tuned.